Hey guys, welcome back. We were dealing with the addition of steam across the double bond of an alkene to make alcohol. So it was the first method of alcohol preparation which we have done, and I have completely informed you about the conditions which will be used for this process. And remember this thing that sometimes examiner is asking about the conditions only very directly. Okay, so right now we are shifting to the next page, and that is related to fermentation. I am writing very clearly. It is a fermentation, and this is another method for the preparation of alcohol. This is a method through which we are preparing alcohol industrially. Basically, we are requiring sugar solution, or you may say starch solution, or you may say starch solution, or it can be fruit juice as well. Okay, so means any name can be used, but all of them are basically the same. Okay, so sugars are the forms of forms which are existing in the fruit juice as well. A specific sugar which is existing in the fruit juice is called as fructose. Those students who are studying biology as well, they know this thing that sugars have different types, basically fructose, glucose, maltose, dextrose, lactose, etc., etc. So all these, the family of the compounds which are ending it their name with O's thing is called as sugars. Okay, so all of these substances which I have mentioned here are sugar containing substances. Okay, now, when we are going to use fermentation, what we are using basically, so there should be a biological catalyst, and that is called yeast. What is a biological catalyst? This is basically an enzyme. So it is a biological catalyst which is called yeast will be present here. And remember this thing that there should be no oxygen. I am very clearly writing in the conditions for the reaction, and I will explain every point one by one, inshallah. So right now it is a temperature from like 18 degrees Celsius to 40 degrees Celsius or 38 degrees Celsius might be. You will see this temperature as well, but this is the overall bracket of temperature. So here, along with ethanol, this is a method which is specifically used for ethanol, which is also called as ethyl alcohol. Along with this, carbon dioxide is produced as well. Okay, now let's have a discussion about this method, guys. I would like to inform you that yeast is a biological catalyst. Okay, so if it is a biological catalyst, what is the difference between biological catalyst and the regular catalyst? You may say those catalysts are either industrially based catalysts, or they are the catalysts which are not existing in the life. For example, these metals or etc etc which are used as a transition block elements, which are used as a catalyst of different chemical reactions, are not existing in the life. I mean to say, not part of living organisms, but yeast itself is a living organism. Guys, you might have seen this thing that while making a pizza dough, or while making any food product in which we are adding yeast, for example a bread dough or etc, if yeast is added into a lukewarm water, it is a warm water, which is not a boiling water or very high temperature water. No, it is a warm water in which you can simply immerse your finger, and it seems it is giving you a warmer feeling. Okay, so that's called lukewarm water. And if you are going to put like a smaller amount of yeast into it and covering it for like 10 to 15 minutes, you can see this thing that bubbles are getting formed at the top of the surface, and yeast is growing. You may say it gets swollen. Okay, so it's like that. So yeast is a biological catalyst, and it respires anaerobically. Now, what is anaerobically? Okay, so guys, the point is this, that there are two types of respirations. Okay, what is respiration? It is inhaling and exhaling of oxygen and carbon dioxide. You may say inhaling and exhaling process combined thing is called as respiration. So we are inhaling air inside us, and as a result of that, oxygen of the air is being absorbed in our lungs, and it is reacting with oxygen. It is interacting with blood of our blood supply of our system, and as a result it is making oxyhemoglobin, a compound. So this is the biological chemistry of that side, which is not part of your syllabus, but I'm just bringing your attention to the point that there are two types of the respirations. One of the respiration is called as aerobic respiration, whereas the other respiration is called as anaerobic respiration. In case of aerobic respiration, which we are performing as well, we are based upon oxygen, and we cannot respire in the oxygen free environment. So if oxygen level is getting lesser, for example, whenever we are moving on to a high altitude area, on the mountainous area, so as a result the oxygen level is getting lesser. When oxygen level is getting lesser, we can see this thing that sometimes it is difficult to breathe in that case. Okay, so these are the reasons related to that. So there is another type of the respiration as well, which is called as anaerobic respiration. What is anaerobic respiration? It is a type of respiration in which an organism is respiring without oxygen. So yeast is an organism which is respiring without oxygen. Okay, so we must ensure that while doing this fermentation, the whole system must be covered, whole system should be air free, whole system should be oxygen free, so that oxygen may not be provided. Otherwise the yeast will be denatured, the yeast will not do its work properly, because oxygen will be there, hence it cannot respire, hence it cannot work out properly. Okay, now there is another question, and that is related to the temperature bracket. If temperature will be increased from this temperature, yeast will be remain inactive, and as a result yeast will be destroyed, you may say. Okay, so it can be denatured, unreactive in both cases, if you are going to increase the temperature or if you are going to supply oxygen. Remember this thing, you may write these terminologies, it will remain inactive, or you may say that it will become denatured. So these are the terms which we can use to describe about a catalyst like this. Okay, now examiner is asking in one question paper that how student will know if a student is preparing this ethanol by this method, how student will know that the ethanol production is started. Now the point is this, that when carbon dioxide will be produced, it will just release the bubbles of carbon dioxide through that solution. You might have seen this thing, or rather observed this thing. See, you must have seen, but I am talking about observation. So, for example, whenever we are opening the bottle of a fizzy drink, as a result, the bubbling is observed. And what is the reason behind that? Because all these fizzy drinks are the carbonated drinks. Okay. So, what is carbonated drink? It is a drink, it is a liquid in which carbon dioxide is filled under pressure. Carbon dioxide is relatively less soluble. I mean to say, it is sparingly soluble. Sparingly soluble means it can be dissolved in water under pressure, and when that pressure will be released, it is coming out of that water. So if you have observed this thing, that when we will remain open that bottle of fizzy drink, what will happen in that case? All the carbon dioxide will start coming out of it. Bubbles are forming with a greater speed in the start, with a lesser speed after a smaller interval of time, and then they will be no more. Then they will be finished. Then there will be no more bubbles. And why it is so? Because carbon dioxide, which has been dissolved under pressure, is now no more there. Okay, so here if we are talking about ethanol and carbon dioxide production, we can say this thing, that examiner is if he is asking about how a student will know, then you can answer this thing to examiner, that when student will observe the bubbling in the solution of ethanol in the solution, or you may say in the solution, when student will observe bubbling, it will just give an indication to him or her that ethanol production is started. Okay, then he may ask this thing, that how student will get to know that ethanol production is stopped now. So already we know this thing, that carbon dioxide gives a test with lime water. So if carbon dioxide will be produced, it will start turning lime water milky. So we can mention this thing, that when carbon dioxide gas is produced, it is starting lime water milky. So when it is stopped, when this lime water milky thingy is getting stopped, when it is no more turning the lime water milky, it is just giving us an evidence that this process of ethanol production is stopped. So this is how we can talk about the ethanol and carbon dioxide. This is how we can say this thing, that sugar solution is there, and what is the temperature, and why yeast is used, and why oxygen should not be there. Guys, I would like to bring your attention back to the point of the catalyst thing. So what is a catalyst? A catalyst is a substance which speeds up a chemical reaction by lowering down the energy of activation and by selecting an alternative pathway with lesser energy of activation, you may say. Okay, similarly, a biological catalyst is also lowering down the energy of activation of that reaction. Basically, yeast is, or a biological catalyst is speeding up a chemical reaction, you may say. Okay, so this is how fermentation is being carried out. Now there is one more question, that this fermentation, when it is carried out, this solution is ethanol plus water in it. So it is just 15% ethanol in it. So how we can shift this 15% ethanol to a more concentrated solution of ethanol? Or basically, when we are doing this procedure, 85% of ethanol is prepared. And what is this? It is basically fractional distillation. Fractional distillation is carried out to separate ethanol and water from each other. Guys, I have just told you at the start of this topic of alcohols that alcohols are 100% soluble in water. So when we want to separate alcohol, the ethanol which is prepared here in this fermentation process, if we want to separate this from water, what we have to perform? We have to perform a fractional distillation process. In case of fractional distillation, what is happening? Water has a boiling point of 100 degrees Celsius, whereas ethanol has a boiling point of 70 degrees Celsius. So what is going to happen? 70 or 78 degrees Celsius, it is like that. Okay, so it is going to boil at that boiling point, and all the ethanol will be separated like at 78 degrees Celsius. And now when the temperature will be 79 degrees Celsius or 80 degrees Celsius, it is just giving you an assurance that there is no more ethanol present in the mixture flask. So just recall that concept of simple distillation and fractional distillation. It is advised that you people should look into those videos as well, so that you people may have a clear idea about the fractional distillation and simple distillation. And after the temperature of boiling point of ethanol, which is when it will be crossed, it will just giving you an evidence that no more ethanol is left. So these are the questions which are related to this topic. Examiner is asking about the reactants, about the products, about the conditions, why temperature is this, why oxygen should not be present, what is the purpose of yeast, how student will know that ethanol is being produced, how student will know that ethanol production is stopped, if ethanol produces only 15%, how we may increase its amount, how we may increase its concentration. So these are all the questions which are related to this you should keep in your mind. All right, okay. Now I am taking you to the next point, and that is related to the topic of carboxylic acids. Okay, guys, it is another family, it is another homologous series of organic compounds. So, number one was alkane, which we are done with. Number two was alkene, which we are done with, thanks to God. And the number third is alcohol, which we have just finished. Okay, now it is carboxylic acids. All right, guys, I would like to bring your attention to this point that carboxylic acids are basically compounds which have C double bond OH and this. Okay. So, guys, what is this C double bond OOH? This is a functional group of carboxylic acids family. Here I'm writing it is a functional group of carboxylic acids. So, all the chemical reactions of carboxylic acids are based upon this functional group. Number two point is this, as carbon has to make four bonds always. Here it is making one here, second here, third here. Definitely fourth bond will be here, and and this bond is connecting this carbon with the remaining part of the carboxylic acids. Okay, now there is one exception which I'm going to tell you shortly. But before that, for example, just have some practice of writing the formulas of the carboxylic acids. Guys, before moving towards the writing practice, I would like to tell it to you this as a trick, that while writing the carboxylic acids formula, it is advised that all of you should write the carbon atom first. This carbon atom of carboxylic acid first. Okay. So let's write the formula of the number one. What will be the name of number one? I have told you that meth is the word which will be used whenever there is one carbon atom. Eth is the word whenever there are two carbon atoms. So it's like that. So for example, if you are writing the formula for methanoic acid, okay, methanoic acid, what will be the formula for this? It will be C double bond OOH. Just like the trick I have told you, that we have to write the carboxylic acid first. So we have written this first. Now, how many carbons are written? One carbon is written already as a part of the functional group. Now, in case of methanoic acid, as there is only one carbon atom, so we are not going to add another carbon atom. And what we are going to write it here, H over there, okay? So what will be the formula? Basically HCOOH. So guys, this is the exception. Basically, in case of methanoic acid, the general formula has one carbon atom already. All right. So general formula has one carbon already. So when we are saying that it is the general formula is like CN H2N plus 1 COOH. Okay, so general formula has these two things. Functional group has one carbon already, so we can say this thing that this is the exception, that general formula, this is the general formula. General formula of carboxylic acids is not implementable on the first compound, which is called as methanoic acid. And why it is so? Because general formula has two carbons in it, whereas methanoic acid has only one carbon in it. So this was the exception which you need to keep in your mind. I would like to bring your attention to the next compound so that this concept may be better or clearer further related to this. Okay, so if it is asked that to write down the formula of ethanoic acid, okay, ethanoic acid, it is just telling you that it will have how many carbon atoms in it? Two carbon atoms. Okay, so first of all, I will start writing the carboxylic acid function group, carboxylic group. Okay, so now you can see this thing that one carbon atom is already written. And in case of ethanoic acid, how many carbon atoms should be there? Two carbon atoms should be there. So we are going to write one more carbon atom, and that's it. And remaining, these are fulfilled by hydrogen atoms. Okay, so this is how we are going to write down the formulas of the carboxylic acid. I would like to bring your attention to the next formula as well. So for example, if the compound is propanoic acid, okay, in that case, propanoic acid, first of all, we will write propanoic acid. It is just telling you that it is a three carbon atom compound. So first of all, we are going to write C double bond O, and H. So it is the carboxylic acid group, okay, carboxylic group, okay. So one carbon atom is already written. Now, how many carbon atoms are left? Two more carbon atoms are left because we have to complete the three carbon atom thing, okay. Now, as per the basic practice, each of the carbon atom has to make four bonds. So this central carbon atom has made two bonds, so it will make two more bonds. This last carbon atom, which is called as a terminal carbon atom, has made only one bond, so it is just making three more bonds. So I am mentioned here this carbon, which is at the end, it is called as the terminal carbon. So this is how we can write down the structural formula or the displayed formula for propanoic acid. So what it can be C2H5COOH. So this is what called molecular formula. Might be you are thinking that why she is not combining these two carbon atoms. Yes, we can combine, hence it will become C3H6O2. So this is also the same. This is also the same, but I would like to advise you that either write this or write this. Okay, otherwise the things will be in the problem. All right, take care of yourself. Allah Hafiz.